So this is a video response to Veritasium's 4 Revolutionary Riddles video. I'll have a link down in the description so you guys could check out the video for yourself before watching mine, and you can have a look at what I believe are the solutions. So the first problem is there is a cylinder on a plane, and instead of rolling down at a constant acceleration, it would decelerate, stop, and then start rolling again. So I believe that there is some sort of liquid inside, where if the cylinder starts to roll, the friction on the liquid by the cylinder would cause the liquid to roll back to the back end of the cylinder. Then the cylinder would have a center of mass closer to the left, and at this point it would stop for a second, and then once the liquid resettles after a certain amount of time, the cylinder starts to roll again and the process repeats, where if it starts rolling again, the friction would move it back, and then it would stop for a second, and then keep rolling. However, I don't know if the liquid is water. I believe that it's not water. I believe it's something denser, because I don't believe that water would cause the cylinder to stop for as long as it did in the video. So the second problem asks, if there was a bike, and there is a pedal with a rope attached to it, ignore my drawing, and if the rope is pulled back, will the bike move forward, back, or stand in place? I believe that the bike will move forward, because the only difference is what's applying the force to the pedals, whereas normally it would just be a foot pushing down on the pedal causing it to turn. This time there's just tension from the string, and no matter the gear ratio, the wheel back here is going to be causing the bike to go forward. Third problem asks, if someone ran around a track at one velocity, let's call that velocity initial, what would their second velocity when they run around it again have to be, so that the average is 2 velocity initial? Now, velocity average is velocity initial plus velocity final over 2, and we want that to equal 2 velocity initial, and we could just do some algebra. So we get velocity initial plus velocity final equals 4 velocity initial, and velocity final equals 3 velocity initial. If we plug that back in here, we'll end up with velocity initial plus 3 velocity initial over 2 equals 2 velocity initial. And we'll get velocity initial plus 3 velocity initial equals 4 velocity initial. And we have 4 velocity initial equals 4 velocity initial, which means the equation checks out. So the fourth problem is asking, if there's a train moving along train track at a very fast speed, I think speed doesn't really matter in this case, there is a part of a train that is moving backwards with respect to the ground. Now, the actual train itself, not counting the wheels, is always moving forward. There's no moving parts or on the outside, and if there are moving parts on that upper part, it'll probably just be on the inside, and we could count that out. I believe the solution is within the wheels, where the wheel itself is always moving in one direction, but it also has rotational motion, where the top part is moving forward and the bottom part is moving backwards. And if there is a part of the train moving backwards, it's going to be the bottom half of the wheel. And just to demonstrate this, imagine that this wheel is moving forward, and that there's one point going across the wheel. It's going across the top, it's going forward, and then it hits the middle line, separating the top and the bottom, and the bottom portion is moving backwards. And the portion in the bottom that's moving backwards the fastest is going to be this middle bottom part, because it's the farthest from this line separating forward and backwards motion. Yeah. However, I did just realize that if the slowest point, or the point that's going back the most on the train wheel, is the middle bottom part, then that must mean that all other points are moving forward because the middle bottom part isn't moving backwards, it's stationary because it's touching the ground. So, as for an actual solution to riddle number 3, I don't have one. Besides that, the slowest point, in my opinion, is the middle bottom. However, it is not moving. I do want to take this moment to thank Veritasium for creating the amazing educational content about real-world science and philosophy that I really don't get to see much of in school. One of my favorite videos from Veritasium is titled, "Is This What Quantum Mechanics Looks Like?", which I strongly suggest checking out. It's one of my favorite because he goes into theories in the quantum mechanics field which I have never heard of, while showing examples with a drop of water which can easily be replicated at home with enough effort. I'll make sure to have the video linked down in the description. And thanks for checking this out.